The Ben Heck Show is brought to you by Element14, the electronic design community and online store built for engineers and hobbyists alike. Join now and browse the store at Element14.com.
Benjamin J. Heckendorf. Every week he takes on new projects, shares tips and tricks, and answers your viewer questions on The Ben Heck Show.
Hello and welcome back to The Ben Heck Show. Today the question is, trick or treat? I say both. In the spirit of Halloween, we're building a prank candy bowl. The idea is your friends or unlucky trick-or-treaters will reach for a piece of candy. The system detects this and then spookily yanks the bowl backwards, along with scary sound effects. In today's episode, we'll get it working mechanically, then add the logic and audio in the next episode. Let's get started. But first, the news. Today on Ben News, I want to show you something we're adding to our America's Most Haunted pinball machine. Inside the cabinet, there's going to be inlays for this RGB strip lighting and then smoky acrylic on top. And this lighting will change based off mode, and it'll also help illuminate the entire game. Take a look. There, just start there.
I found the ghost. It's an insane doctor.
It's changing color.
Surgery, but sadly we ran out of bleachers during the Great War.
I think I can bust through the door and save you.
That seemed to distract him. Now smash this door open.
So here's the basic idea for this project. It's Halloween and the kids are trick-or-treating and they see this table, perhaps in your front lawn, with a bowl on it full of candy. Like, ooh, I want that candy. They go up to get it and then all of a sudden the bowl moves like it's haunted and the kids will probably be like, ah! So we got to figure out how to make that work. I'm kind of thinking maybe some magnets to interface between the bottom and the top of the table. So let's try some experiments. Got some small rare earth magnets here to start. I made a frame for them. You can definitely move the magnets around using the magnets. However, there's not much force to it. So I'm pretty sure this wouldn't work for the bowl. I sense a spirit. It is your great-grandfather. He says something about the money. Here are some larger magnets that I bought at Menards. Okay, you can definitely interface. The magnets are larger so they have more power, but it still doesn't have a lot of force. You certainly can't move a bowl with it. So this table has a card layer, then it has a foam layer. See how my fingers are leaving dents, and then there's a vinyl top. I think what I'm going to do is cut off the foam layer to make a smooth surface, see how the magnets move on that, and then possibly use ball bearings to make it go smoother. So I'm working on the design here for the thing that's going to hold the magnets and the ball bearings. So it's basically a disc with a magnet in the middle, and then it has a channel here for the ball bearings. So what I did was I took this shape, which is 2.9 inches in diameter, multiplied that by pi, then I took that number and divided it by the diameter of the ball bearings. And that tells me how many ball bearings I can fit around that circle. I believe it was like 36.09, so I'm going to slightly increase the size of the circle, so 36 will fit in there with some slop. And while I'm slicing this apart, I'm going to be 3D printing a bracket that will hold the magnets and ball bearings and hopefully give us a smooth motion. Who knows, maybe there's like hidden treasure or mafia money in here.
I'm Batman.
Saw 12. If there is a spirit here with us, move this object. Evidence of ghosts. Pay no attention to my shoulder. Here is our 3D printed bearing thing. And I'm going to load it up with these 1/4-inch ball bearings. It's kind of cool, the ball bearings space out automatically because of the magnetic fields. But we want to pack them in there pretty good, so I believe this will be the last one. Ugh, of course. Seriously? It's like one of those puzzles you can't win. There we go. You know what? I should just bolt it together and stop playing with it. suppose eventually these balls will become magnetized. Oh, really? Airless air hockey. Oh, that's the wrong pole. There we go. Hey, the bowl moves now. Yeah, that's right. Friction 0, bend 1. Pound of candy. I can pray I can still escape its magnetic influence. If there's a spirit with us, move this bowl. Your husband says, don't worry about the money. Everything's all right. Give it to the psychic. The electronics industry is evolving at a rapid pace. Professionals and hobbyists from all corners of the electronics world are coming to a significant realization. We could all use some assistance. Wouldn't it be nice if we could reach out and ask for expert advice when we need it? Our questions drive innovation, and thankfully, Element14 provides us with a way to get the answers we need. With a community of over 100,000 engineers, Element14 offers the fastest project solutions. Members can engage with more than 50 industry-leading experts. With dedicated technology and application groups, free technical documents and technology webinars, 24/5 technical support, and legislation advice, Element14.com is the place to find experts with answers. Free expert support is just one more way that Element14 makes it easy for engineers to be inspired and find the solutions they need to get the job done. And now, back to the show. The magnet idea I don't think is going to work. It doesn't have enough force to move the candy and the bowl. So I'm going to do something more straightforward. I'm going to put an arm through the table and then we'll hide it using the tablecloth. So the bowl will start here on the edge so it can be within reach. So I'll start the bowl at 4 inches in. And I'll give it a throw of about, I'd say about 8 inches would be good. Now there's a slit in the table. I think we'll hook the bowl into that so it can jerk back. But then we got to think of a way to make this smoothly go over the edge. I mean, we could sew in a bar here to weight this down so it pulls itself down. So after the bowl comes back forward, hopefully that would weigh itself down, but it may not. So we'll see. All right, we need to make a way to quickly release the bowl. So I have an expansion spring that's going to pull it away, but we need a way to release it electronically. So I've got the servo, and I 3D printed this disc and it has a slight lip on it. So a hook can go on it, but then when the disc rotates, that'll make the bowl pull away quickly. So I'm going to mount the servo to this mount that I 3D printed, put the disc on that, and then mount it under the table. You'll never take me alive, Sheriff. Which is so dumb. Any bullet would go right through a table. I mean, come on. Hold it there. This is the thing with the tooth I'm going to put at the bottom of the bowl. It's got a expansion spring. Expansion spring is one that expands. Compression is the one that you compress. So I'm gluing this and screwing this in place right now, but what will happen is this tooth will catch onto the wheel thing that we made, and then when the servo rotates, it'll come loose and move the bowl violently back, because we want it to be violent to scare the kids. Oh, are you kidding me, alien? I feel like I'm setting a booby trap. Let's test it out. I'll bring this up. I'll latch it in place onto the wheel that we 3D printed. Then I will send a command, a certain servo position to rotate the wheel, allowing the tooth to be released, snapping the bowl back and scaring kids. It's like a guillotine. I think I'm going to try it in the horizontal position now. Ah! It's a haunted candy dish. Now it's time for a simulation in the Twilight Zone. 1,000, 2. Oh boy! Ah! Ah! Now I have to make sure it still works with the tablecloth. So I'm going to glue the tablecloth in place and then cut a slit where the opening is. If the tablecloth is stuck in place, then it can't really change, you know, it'll be in a constant place. Guess that's kind of obvious. Okay, grab the sides, pull them out. Okay, now down. All right, help me smooth it out. Stick it, kick it, stick it. Burn the edges so it doesn't fray any more than it is. Not quite flame retardant. I thought this must be cotton. If it's nylon, it would have melted. Oh well. All right, let's put some weight in there. Cool, it still works even with the tablecloth. So that's how we're going to make this mechanically work. In our next episode, we're going to decorate this, make it look all spooky, and then put in a microcontroller with an SD card and some speakers so it can make noises and stuff to scare the kids even more. And if we have time, maybe even put in a off-center motor to make it shake and rattle. Today's question comes from Twitter follower Chris, who asks, on the Neo Geo project, how did you wire the JAMA connector's composite sync to the DB9 RGB connector that has both vertical and horizontal sync? Well, even though monitors have pins for horizontal and vertical sync, there's also usually one for composite or combined sync, like JAMA uses. If there isn't a dedicated pin, sometimes you can attach composite sync to either the horizontal or vertical sync and it will work. That's all the time we have today. Join us next time as we add the electronics and finish up the project. We'll show it in action, ooh, and of course enjoy some fun-sized candy bars. We'll see you then.
Stay tuned at element14.com/TBHS, where you can join the discussion, suggest builds for the show, and even have a chance to win upcoming builds. Remember, you can always email build ideas to benheck@element14.com. Thanks for watching.